Ever wondered why the periodic table looks the way it does? This iconic chart is not just a random assortment of squares and letters. It's a meticulously organized roadmap of chemical elements, each with its own unique properties and behaviors. The layout of the table is not arbitrary, but rather a reflection of the underlying science. It's a key to unlocking the secrets of the universe, one element at a time. Now hold that thought as we dive into the depths of the periodic table. Now imagine the periodic table as a grand mansion. The columns, known to us science enthusiasts as groups, are like different wings in this mansion. Each wing or group houses elements that share similar traits. They're like families living under the same roof, yet each member is unique in its own way. In this mansion of ours, there are 18 wings, each representing a group in the periodic table. Let's take a brief tour, shall we? Our journey begins with Group 1, also called the alkali metals. They're like the fun-loving, energetic folks you'd always find at a party. They're highly reactive, especially with water, and are never found alone in nature. Next door in Group 2, we have the alkaline earth metals. These guys are a bit calmer than their neighbors, but still quite reactive. They're commonly found in the Earth's crust, hence their name. Moving on, we come across Groups 3 to 12, the heart of our mansion. These are the transition metals, known for their ability to mix and match with other elements. They're like the social butterflies of our mansion, making friends with almost everyone. Then we have the post-transition metals in Group 13 to 15, known for their versatility. They're the jack of all trades, found in a variety of compounds. In Group 16, we meet the chalcogens. They're the essential life-giving elements, including oxygen, which we all need to breathe. Group 17 houses the halogens. They're the salt producers. They're the chefs of our mansion, always cooking up something interesting. Finally, in the last wing, Group 18, we have the noble gases. They're the introverts, preferring to stay alone and unreactive. So in essence, each group houses elements with similar personalities. Pretty neat, right? Now, if the groups are the wings, then the periods, the rows, are the floors of our grand mansion. Imagine our periodic table mansion as a grand 7-storied building. Each floor, or period, represents a different energy level. As we move up each floor, the energy level increases, much like climbing a staircase. Starting from the ground floor, we have the first period. It's the smallest floor, with just 2 rooms, or elements, hydrogen and helium. These two are the building blocks of the universe, and they occupy the first energy level. Moving up to the second floor, we find 8 rooms. Here's where we meet elements like carbon, nitrogen, and oxygen. Each element on this floor has 2 electron shells. The inner shell is full with 2 electrons, and the outer shell is filling up, accommodating up to 8 electrons. The third floor mirrors the second, with 8 rooms again. This is where we find elements like sodium and magnesium. Just like the second floor, elements here have 3 electron shells, with the outermost shell in the process of filling up. Now we reach the 4th and 5th floors. These are larger, with 18 rooms each. Here, we find transition metals like iron, copper, and zinc. These elements have more complex electron configurations, with the 4th and 5th electron shells filling simultaneously. The 6th floor is even bigger, housing 32 rooms. Here we meet the lanthanides and actinides, elements with complex electron arrangements that involve the filling of the F shell. Finally, we reach the 7th floor, our current frontier in elemental discovery. It's incomplete, with ongoing research to discover and confirm new elements. Remember, elements on the same floor or period have the same number of electron shells. The period number indicates the highest energy level an electron occupies in an atom of an element in its ground state. So each floor or period represents a new level of energy. Fascinating, isn't it? Now, let's shift our attention to the heart of our mansion, the transition metals and the inner transition metals. The transition metals, those occupying groups 3 to 12 on the periodic table, are a fascinating bunch. They're like the chameleons of the element world, with their ability to form compounds in many different colors. But that's not their only party trick. These metals can also exist in multiple oxidation states, which means they can lose different numbers of electrons and still be stable. This unique property makes them incredibly versatile and important in many chemical reactions. Among the transition metals, we find some of the most well-known elements such as iron, copper, silver, and gold. These are not just precious metals that we value for their beauty, but they play crucial roles in our daily lives. Iron, for example, is a key component of hemoglobin, the molecule in our blood that carries oxygen. And gold, well, aside from adorning our fingers and necks, it's also a highly efficient conductor of electricity. Now, if we take a step further into the heart of our mansion, we encounter the inner transition metals. These are the lanthanides and actinides located at the bottom of the periodic table. They're kind of like the basement dwellers of the periodic mansion. The lanthanides, also known as the rare earth metals, are crucial in the production of high-strength magnets and phosphors, the substances that make your TV and computer screens glow. The actinides, on the other hand, include elements like uranium and plutonium, which are known for their role in nuclear energy and weapons. It's important to note that many of these inner transition metals are radioactive, which means they can be dangerous if not handled properly. But when used responsibly, they have the potential to provide significant benefits, such as powering our cities and treating cancer. These metals, residing in the heart of our mansion, hold unique properties that make them stand out from the rest. Having explored the mansion, it's time to summarize our grand tour. We began our journey by unveiling the groups, the columns of the periodic table. These 18 vertical columns represent families or groups of elements with similar properties. We've seen how elements in the same group share the same number of valence electrons, which influences their chemical behavior and reactivity. We then embarked on a journey through the periods, the rows of the periodic table. Each period represents a new energy level being filled with electrons. There are 7 periods in total, and as we move down the table, elements become heavier and their atomic radii increase. Next, we encountered the transition metals, those metallic elements that serve as a bridge or transition between the two sides of the table. These elements, found in groups 3 to 12, are known for their ability to form a variety of different ions and for their wide range of physical and chemical properties. Our tour also took us to the inner transition metals, located at the very bottom of the table. These elements, including the lanthanides and actinides, are less well known but play crucial roles in technology and medicine. They are typified by their large atomic numbers and complex electron configurations. Throughout our journey, we've seen the periodic table's importance in understanding chemical elements and their properties. This table is a roadmap, guiding us through the intricate landscape of elements, their reactivity, and their connections to each other. It's a tool we use to predict how elements will interact with each other, to identify trends, and to make sense of the complex world of chemistry. And with that, we've navigated the grand mansion of chemical elements, the periodic table. Remember, understanding its structure is the key to unlocking the mysteries of chemistry. Before we part ways, here's a food for thought. Have you ever wondered what lies beyond the current end of the periodic table? Is it possible that there are new elements yet to be discovered? Could there be a whole new group or period that science hasn't even touched upon yet? It's fascinating, isn't it? The periodic table, as we know it, might just be the tip of the iceberg. So keep pondering, keep exploring. The world of chemistry awaits your discovery.